Here we have a problem in hand. A force of 20 Newton acts on a block. The block acts on a block. The block is having three separate blocks, that is M1 with 5 kilogram, M2 with 3 kilogram, and M3 with 2 kilogram. The force acting on it is F is 20 Newton. First, let us represent this in an image. So we have three blocks, M1, M2, and M3, which are attached to each as shown in figure. So here we are applying a force in this direction. So these blocks moves, which has an acceleration in the same direction. The first question is to find the acceleration of each block. As we see in this image that all the blocks will move with same acceleration because we are applying a force in this direction and all the blocks are connected to each other, so they will move as if they are a same body. So they will move in a same direction. So the acceleration is equal to, from Newton's law, we know that acceleration is force divided by mass. So here force is 20 Newton and mass is the total mass of the system. So M1 plus M2 plus M3, that is 5 plus 3 plus 2, that is 10, which is equal to 2 meter per second square. So we know that the acceleration of each block is 2 meter per second square. Now we need to find the contact force in each blocks. So how can we find the contact force in each blocks? For that we need to adapt, or we need to use a technique that is known as Freebody diagram. So what is Freebody diagram? Freebody diagram is a technique in which we represent, we consider the body as a point mass and we represent all the forces acting on it. For example, let's take our M1. So we have M1, we are considering M1 as a point mass, and we have to represent all the forces acting on M1. So what are the forces acting on M1? M1 alone. We know that it has a mass, right? So there will be gravity acting on it downwards, M1G. And we know that there is a surface holding M1. So this means that surface is acting a force, the surface is providing a force upwards by Newton's third law, which we can call it as normal force, that is N1, which is equal and opposite to M1G. And we are applying a force F 20 Newton to this direction. Since there is a contact surface here with M1 and M2, so that contact surface will be providing an opposite reactive force opposite to the direction of force. Let us call this as reactive normal force N acting on 1 from the object 2, that is N12. So equation of motion for M1 in this free body diagram, we can write it as the difference in forces, that is F minus N12 is equal to the M1 times acceleration of the body. And we know that F is 20 Newton. So what we need to find is normal force in this surface. So one normal force in this surface N12 is equal to F minus M1A, which is equal to 20 minus M1 is 5 and A is 2, 10. That is, we have N12 is 10 Newton. So the contact force on M1, the contact force acting on M1 is 10 Newton. Now, similarly, we need to find the contact force acting on M2. So how can we find it? We use the same technique, this free body diagram. So the contact force on M2 can be calculated using free body diagram of M2. What are the forces acting on M2? We know that gravity, M2G, and normal force, let's call it N2, and this force from M1 to M2, we can write it as, let's say, N21, and an opposing force from the surface M2 and M3, which that we can call N23. So the equation of motion for M2 is N21 minus N23 is equal to M2A. We know that N21 is 10 Newton. That is here. It is just opposite to N12. So we need to find N23, which can be written N23 is equal to N21 minus M2A. We know that M2 is 3 kilogram and A is 2. That is 10 minus 6. We will get 4 Newton. Similarly, the contact force in block M3 can be calculated. We have M3G acting downwards and normal force N3. And what we have here is the force acting on N32. And we know that there is no other contact surface in this side of M3. So the equation of motion is N32 is equal to M3A. That is, M3 is 2 kilogram times A is 2, which is equal to 4 Newton. So now we have calculated all the four contact forces, sorry, all the three contact forces in. So now we have calculated the acceleration of the three bodies as well as contact force in each surface for M1, M2, and M3. So this problem is over.